Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is separation. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A that contains an element A1, A2 till AN as well as an integer x. Now x is said to be separated if there exists at least one index I such that the element AI is less than x and the next element AI plus 1 is greater than x, or the element at I is greater than x and the element at I plus 1 is less than x. That means x is said to be separated in A if A consists of a pair of adjacent elements with one of them being strictly less than x and other being strictly larger than x. Now we can freely rearrange the elements of A however we like. Now we need to find out whether it is possible to make x not separated. So for the input format, we have t test cases, and for each test case we will have two lines. The first line will contain the integers n and x. And the second line will contain n-spaced integers a1, a2 till an. As for the output, we simply have to output yes or no. Yes, if there exists a valid rearrangement such that x will not be separated. As for the constraints, number of test cases will go from 1 to 10 raised to 5. Value of n, that is length of our array, will go from 2 to 2 into 10 raised to 5. And the value of elements in our array A and value of x will go from 1 to 10 raised to 9. Let's see some sample inputs. So for the first sample input, the value of n is 4 and x is also 4. And the elements in our array are 1, 5, 2 and 4. Now, we need to rearrange this in such a way that x will not be separated. So let's sort this. So after sorting this, this becomes 1, 2, 4 and 5. Let's go over each index and find out whether that makes x separated or not. If we stand at 1, this index is less than x, but the next index, the adjacent one, is not strictly greater than x, rather it is small, so this is not going to make x separated. Similarly, we can find for 2 and 4. Here again, 2 is strictly less than x, but 4 is not strictly greater. We need to find something that is strictly greater. This is equal. The same will go for these three indices. Therefore, it makes it not separated, and our answer is yes. Let's see how we can approach the solution. So as we have seen in the sample input, if the numbers are all small, we don't have to bother about the adjacent or pair satisfying the condition. The same goes when we have numbers that are greater than x. So if this is x and these are the numbers that are smaller than x and these that are greater than x, we are only worried about the borders, because only here it can happen that we have a number that is strictly less than x and here a number that is strictly greater than x. So let's see in which cases we can confidently say that our answer is yes and it will be not separated. Those cases would be if the left is empty, that is, there are no numbers smaller than x. In that case, there will be no adjacent that satisfies the condition that ai is strictly less than x. So our answer would be yes. Similarly, if the max is empty, right? So if our min or our max, both I'm talking respective to the x, if these are empty, our answer is always going to be yes. And another case would be that if x itself exists, if that is the case, then even at the boundary case, we will not be able to fulfill the condition of it being strictly less and strictly greater, because it will end up being equal. So the condition will fail. So either our x is less than min, either our x is greater than max, or x is present in our array A, our answer is yes. In all other cases, our answer would be no. And with this, we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and x. Then we take the input of our array and we find the minimum and the maximum element in our array. While doing so, we'll also check if x exists in the array. For that, we'll use a flag called xFound. Now, In case our x is less than the minimum in the array, or our x is greater than the maximum, or we find x itself, then our answer would be yes. Otherwise, our answer would be no. And that is what we print here. And as you can see, I've got an EC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. We take the input of n, x, and then our array. We find the minimum, the maximum, and we check whether x exists in the array. If our x is less than the minimum element, or our x is greater than the maximum element, or x exists in our array, our answer would be yes. Otherwise, our answer would be no. And as you can see, I've got an EC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.